we have our last presentation here. This is the automated fisherman, but I want to remind everybody that under the about in our channel, you can actually see the program. There's a link to the program, and there's a link to actually vote for best project. So feel free to hop out there and vote for the best project. So I'm going to turn it over now to the automated fisherman.
All right, so good morning, everybody. My name is Nathan Allen. I am here with David Sharmer and Riley Cutsley, and we are here today to present to you our senior project we worked on this semester, the Automated Fisherman. So in this presentation, we'll go through some of the overview, the purpose of our machine itself, some of the flow charts, some of the program, some of the controls as well. Then we'll finish up with some of the troubles that we ran into, and then along with that, some of the future upgrades that we might want to implement as well, if we were to continue working on it. So as you can see here, the greater purpose of this machine is to catch a greater number of fish without having to consistently hold and monitor your equipment. So right now we have it set up to be work in two states. So you can either do standard ice fishing, where you drill a hole in the ice using an auger and just feed line in and out through that hole to fish stationary, or you mount this thing to the tail end of any sort of fishing boat. You can troll for fish in that manner as well. Both are set up to work. So this machine greatly reduces the human error aspect as well, especially with any sort of really inexperienced fishermen or just younger children in general. The general tendency is with the first time they get a bite on the line is to reel in as hard as you can, as fast as you can to get that fish in. When that tendency happens, you have more likely to have a line break, have the line snap, or the fish to get off. This takes that element out of the equation. Along with that, it also has a low base, and the controls themselves, they sit low, so it is also handicap accessible as well. So we'll get behind some of the controls we got going on here. So what we're using for our HMI is a PanelView Plus 6600 HMI. That's what we're using to run through the entire program to be able to set your fishing depth, be able to control when you want to reel in, reel out, all your fishing condition sensors as well, everything you can see using that HMI. Along with that, we are using a Compact Logic 1769 L18 controller, which also has embedded I/O, 16 input and output points as well. Along with that, we have two expansion I/O modules as well. We got a 1734 IE2V and a 1734 IE4C. One of those is our 0 to 10 volt analog input, and the other is our 4 to 20 milliamp analog input. So for be able to detect a fish bite, we ended up using this thing called a flex sensor. And what it is, we have it mounted on the very end of our fishing rod. We actually have a little bit of the fishing rod taken off and replaced with the flex sensor, and then some of the line going through the eyelet connected to the flex sensor itself to help increase the overall bend of it. What it is basically it changes the output resistance value based on how much you bend the sensor. So that's how we're able to detect when a fish is biting in on the end of the line. As you see here, we just have a simple voltage divider converting that 24 volt input from our power supply into a 0 to 10 volt range that we can use for the card. So we were maxing out somewhere a little shy of 8 volts at its maximum bend. So that's well within the 0 to 10 volt range that we're given. Yep. So in terms of line depth, it's important to be able to track how far, how much line you've let out, how much line you've let in, where you are at all times in the fishing process. So what we ended up using is Hall effect sensors and pair with magnets. So these Hall effect sensors, each side of the sensor we chose can detect one pole of the magnet, and it's all based on the flux density, the magnetic strength of that magnet to determine when the output goes high and low. So if you see on the next slide here, we went with the A3144 Hall effect sensor. So as long as no magnetic field is detected, the output remains high. And then the moment a magnetic field is detected, the output goes low. So that's how we're able to determine and count pulses in that manner where we are at all times during our fishing depth. So we also ended up using a 10K ohm pull-up resistor as well to keep that output high when there was no magnetic field detected. So we ended up using 2 sets of neodymium magnets as well, one on each side of the bail. They sit across from each other, and every time they pass the Hall effect, one pulse is done going low and going high. So that's how we can determine the actual line depth. You'll see later on when David goes over the logic itself, we use normally closed contacts in our ladder logic, and that's the reason why they're normally closed, is because of that, the aspect of that Hall effect sensor. So, and then we also have air and water temp being measured as well. So we are using RTDs. Those are the transmitters up in the right corner, if you could see those. And then we also are using the scale with parameter instruction to be able to scale that raw data value into something we can understand. So all it's doing is taking that input value, which is somewhere between 4,000 and 20,000, so your 4 to 20 milliamp, somewhere in there, and then it's converting that into a degrees value in Fahrenheit that we can understand and then display to the user. So, and with that, I will turn it over to David, and he'll kind of go over some of the HMI and some of the programming as well.
Hi. Yeah, so some of our page displays that we have our kind of like just the welcome display, the display that pops up right when we power on. We have our set hook and lure to water level. So what that's really doing is when we go to the water level and you hit the confirm button, that's going to be important later, but that's when we actually start sensing like the Hall effect sensors. So we're actually tracking like actual depth then. Then we can enter our fishing depth if we're in like auto mode. Then we go to this page here, which is showing us our like a real-time depth in feet and inches. We have a water temp and an air temp here, and that's kind of a selection panel there. So if you have nothing happening, like if you're not going down to your automatically set depth that you want to, you go to our nothing happen page, and what that does is that basically takes you around to the set your depth, set your water level depth, because you missed a confirm in that case. So that's what kind of goes back and helps you out there. You have a continue fishing, so you keep fishing at there. A done fishing, which is going to bring you back up to your water level or that 0 point that you set. And like I had already talked before, the Mr. Confirmation button press. So here's some of our flow chart. So a big safety feature we had is like if you're going to be messing with a lure or the bait that's actually on your hook, we don't want like someone to come along or you'd be able to like start reeling in or reeling out while you have hooks in your hand. So we have a proc switch on the back that we demonstrated with a spring to kind of keep it back there, that as long as you're on the proc switch, you can't energize the motor, which won't reel in or reel out. So then we have the confirmation button, like when you're at your water level, you can go into manual mode, which is just going to let you reel in and reel out. That's all that's really going to do. Excuse me. And then you have your automatic mode. So then you would go through, you like set your depth, and then that's just basically just doing a comparator. So you have your desired depth and your actual depth. It's going to, when your desired depth and actual depth equal each other, it's going to shut the motor off. Okay, so yeah, like I said, the motor stops. So then you're kind of like fishing at that point. So you have an option just to kind of stay there, wait for a fish bite. You can click done fishing. Either one of those is going to bring you back up to your water level set point that you started out, you initiated. And you can also change depth. So if you want to change your water depth, you're tired of fishing at, let's say 5 feet, you can raise or lower, and it's going to track that based off those pulses that Nathan was talking about. Those pulses are around like 1.5 inches. So that's kind of how we like track line depth. Sorry, can you go back one just so I could see? Okay. So then, as Nathan was talking about our flex sensor, like once you get a fish on, that's going to cause a bend, and we're going to sense that. So we're automatically going to reel up. And then at any time, you can go to the next one. Like if that goes, like if the fish releases that, you lose that tension on the rod, then it's going to remain at that level. And what we do then is we push like the current depth value to become your desired depth. So you're just remaining there. And it's the same thing. You can change depth if you want to go back down to where you were, if you want to stay there for a minute to see if the fish bites on again. And so that happens, or it's going to reel up if the fish is staying on. And then at that point, when you like catch the fish, like it's at the 0 point set point, you can bring in your lock in your proc sensor, which is also going to kind of help raise the fish up a little bit, and you can stop fishing from there or keep on fishing if you like. Here's like a little bit of the logic that we went through. So we have our it's shut down, so we're not getting like real values in at this point. But as long as we get greater than like our value that we had set, so we had like 72.50 as our value, we're gonna get our fish bite in. And then as long as like we're not equal to 0, which is like that 0 set point, and you're not automatically reeling out, so you're not gonna basically energize the motor, twice, try to reel out and reel in at the same time, and your confirmed depth counter is done, then you're basically going to have your fish bite, which is going to let you reel in. We add a little timer in there just to kind of help prevent like spurious values coming in from the flex sensor. And then, I mean, it'll also energize a fish on light, start reeling up. So here are like the counters. We're counting up and down pulses with the Hall effect sensors. So we have our lock-in, which is when the confirm button that we push when we're at the water level. So, and then as long as like you're say we're reeling out, so we have automatic reel out and reel out, then we're going to count pulses. So count up and then count down, which are going to like keep track of our depth. And another big thing that kind of came up, we didn't know like how legal it was, like when we were initially looking at like ice fishing and whatnot, like if we could automate this. So we emailed the DNR to see like if that's all right. And they were basically like, yeah, that's fine. Like if you're ice fishing, they don't want you to pretty much set your pole and then just walk away, come back the next day. You just have to be within a reasonable distance of it. But they were kind of all for it. So that's what I was going over. Now Riley's going to go over some of the schematics and budget and stuff.
I know it might be a little difficult to see online, but major part of my part of the presentation was drawings, so it might be difficult to see online. But this is the rod holder that I designed and then had certified sheet metal fabricate for us, which they donated that for our senior project, so I thank them. But it was definitely with flaws. We had to modify it, but as it was donated, we kind of had to make it work, so they didn't have to do it again. But as it sits, it's about 24 inches tall. And our motor mounts right here, which is fun. We put an Allen wrench fits inside the reel, so that's kind of like our one gear for the reel to spin. And then the electrical drawings, which you guys definitely probably can't see, but one of the biggest things was our motor has to go forward and reverse, but only has 2 leads to the motor, so we had to put 2 relays, a forward and a reverse relay, so they could not be forward and in reverse at the same time. You can hit next. And then this is just our IO drawings that we do. You can see our 2 lights and our relays that are outputs, digital outputs. Then here's our temp sensors, which are analog input, which 4 to 20. And then our flex sensor is a digital input, a voltage analog input, 0 to 10 volts. Then you can kind of see our sensors and breadboard here. And then next. And then our 2 transmitters for temperature. Right. And then one of the cool things about where I work at Select Tech, we use SolidWorks Electrical for all of our drawings. And along with that, for each part you put in your drawings, you can put a part number. And then it has like a drawing that's part of that. And you can do a panel layout. So when you're laying it out, you can say, hey, is this actually going to fit in my certain panel size that I want to do? And obviously you make it as small as possible. So you can kind of see that there in the drawings. Next. And then here's our finished panel. Tried to keep it as clean as possible. It was a little bit hard with the breadboard because you're trying to stick wires in a tiny little breadboard spot. If we do it again, we'd probably use like a perforated board and solder them together. It's a little bit challenging. And then another thing with SolidWorks and where I work, we can suck in the data from SolidWorks and it automatically creates a bill of materials. So here's everything that we used within our project in our panel. In the ship loose, we do that too for like sensors and stuff because that's not part of the panel. So that goes in there. And then kind of what we spent on the project, we said we would spend around 250, but we actually only spent around like 118. But this would definitely not be possible without my work Select Technologies. They donated almost everything for us, so that was awesome because we could not have fund it ourselves. And then some questions that we were asked along the way. What powers the PLC? We use a 24 DC power supply that converts 120 into 24. How would this be done, like in the real world fishing? You could either use two 24-volt deep cell batteries ran in series and connect that directly to the 24 main fuse. However, we could not afford those batteries, so we just use 120 power. Or you could use a generator, but no one likes to listen to a generator when they're fishing, so the battery option is definitely the best. And how are the controls protected? We use a NEMA 4X Stalin enclosure so water can't get in, and all of our temp sensors and cords going in have rubber seals on them. And the purpose of the spring on the end of our rod holder is so that it functionally cannot work while it's made. The proc sensor has to be off in order for someone to begin fishing so that they don't end up with a hook in their hand. So with that, I'll give it back to David. Or Nathan, sorry.
All right, so we'll kind of go in depth here a little bit of some of the troubles and issues that occurred along the way. So the main one we ended up fighting with was being able to have those magnets the magnetic field be detected by those Hall effects. Turns out after testing, you have to get within millimeters of each other in order to have that Hall effect recognize that the magnetic field is present. So getting it lined up properly and also to where it would not be struck by any of the rotation of the reel as it's reeling in and out, that was kind of a trickier part for us. And then also the original, like Riley was kind of referring to earlier, the original hole in our rod holder here, you can kind of see, you probably can't see it here, but it's sitting up top there. That original design didn't really work all that great. We had a lot of times where the line would get caught, it would get caught on the line roller, and it would just kind of be cause a mess. So we ended up having to drill a new slot kind of down the center of the rod holder itself. And then we had a few problems reading in the air and water temp values for a while. That ended up being more of a wiring issue than anything else. But we eventually did get it to work. All right, and then finally, I'm going to go over just a few future upgrades. If we were to continue working on this, I think the biggest one would be drag detection. So to be able to detect when a fish is on the line, a lot of times it has a tendency, especially if it's fighting, to take out line itself in order for the line to not break. We were not able to detect that with this system, but ideally you would like to be able to track exactly how much line is being taken in or out by that fish as it's fighting. Another one comes to mind is changing just the base design of the rod holder itself. Right now, it's good for a jet sled for ice fishing and being able to be portable, but it is a little unstable, and we've known from testing that it has fallen over a few times. So that is something we might want to change. Another one would just be maybe like a second proc sensor for additional safety reasons, and then maybe a entirely different method when it comes to detecting line depth, maybe using like a draw wire encoder or infrared like reflective sensors along with the Hall effects, something along those lines for a different form of measurement. So I believe that is everything. So we will take any questions you all have at this time.
So I don't do much fishing, and so correct me if I'm thinking about this wrong, but you said you had a trolling option. How do you deal with like the additional bend on the pole that might come from trolling?
So like, where we had the flex sensor where a value had to be, oh, sorry. The question was for a trolling option, how would we deal with the extra drag from more line or lure or obstacles in the water? The answer to that is our flex value. We have it set at 7250. We could raise that to where it's resting with all of that in the water, and then when it detects a bite on top of that, it'll go over the value.
Have you had a chance to test like how heavy of a fish that you could catch with this thing?
The question was, have we had the opportunity to test how heavy a fish you could catch with this? No, but based on how we designed this, it was for smaller panfish. I mean, obviously, you'd have to upgrade some stuff for like saltwater fishing or salmon fishing.
First, I just want to make sure that I understand it correctly. When it detects a fish, it's just going to start reeling, correct?
Yes.
Okay. So I have my first question kind of revolves around that flex sensor. What kind of things did you implement for a bite sensitivity? Because you might not necessarily have a fish, but it might bite it just enough to where that sensor gets set off, but you might not actually have it.
The question was if the sensor goes off, but the fish is not actually on the line yet, correct?
Yes, bite sensitivity. Yeah.
So basically, we set the value where it had to be great enough to where something actually had to pull on it. So it would actually have to be on the line and pull on it before it would start to reel.
My next question is deals with the motor torque, because obviously, depending on the fish, what is your motor torque set at? Like, where is that at? So that way, you're not ripping the hook right out of the fish's mouth.
The question was, what is our motor torque at? We don't necessarily know what the motor torque is, but we picked a motor that had slow enough revolutions to where it's not like a super fast motor. It's 30 revolutions per minute.
I guess it's my turn. You knew this was coming. By the way, nice job with the flow chart. I just want to also mention, nice job overall. I noticed flow charts in just about every group today, and that's music to my ears and eyes, I guess, if you can say that, because that's just the kind of person I am. I'm a flow charting person. All right. So back to this question that I have, and help me understand this a little bit. But when you have, I think you had like an open bail type reel, right? That's what you use. So typically, when you're casting, you open the bail, but the spool doesn't move. The line just goes out. That's not what you're doing here, right? Repeat that.
Correct. So the question is, typically with an open face reel, you usually have to like move the bail to like let line just free spin out, and that's not what we're doing here. So we're wondering what we're doing here. So there's a lever like on this reel, and it's like the anti-reverse I think lever. So as long as we like disengage that, you're free to spin the lever in both directions, and it will let out and let in. And so we just have the motor controlling that.
Okay, that's the part I wasn't sure about. Okay. So you have the Hall effect sensor that is essentially sensing the revolutions of the reel. Is that correct? Okay. So my next question is, okay, so I'm a retired professor and I'm in my ice shanty. I've got my widescreen TV. I'm watching the Packers. That's Professor Todd, by the way. And so so this thing is outside. It might be 25 feet away. Is there a way to wirelessly kind of have telemetry or some way to know what's happening out there without having to have a huge cable or something?
Now the question was, is there a way to wirelessly accomplish this task? And the way the DNR answered our question was that you have to visibly see that you have a fish. So, like, we have little pilot lights on the front, and we were thinking maybe stack lights on top because it's more visible. But as far as wirelessly, I'm sure there's probably a way that you could connect it to your phone. But I don't know legally if that's possible.
Okay, so it's a legal constraint then. I wasn't sure about that.
Yes, I would say so.
Okay. And I guess one final question. So you said the PLC is 24-volt operated, is that correct?
Yes, it is.
So in a situation where you are out in a remote area, you saying you recommend using batteries, is that correct?
Yes, I mean, there's really no other way to get 24 volts.
Do you know how long such a battery would last and what kind of amperage or whatever this thing requires?
The question was, how long would 24-volt batteries last? Like on my fishing boat, we have an electric towing motor. I don't know the current of it, what it draws, but it'll last 8 hours fishing. So I think that motor would draw more power than what our panel would.
So do you know how much current your device needs?
I did. It's a 5 amp fuse, so not very much current.
Okay, now I guess it's the question they've all been looking forward to, right? Okay, so project management. I know that was a long time ago, right? Two semesters ago. There was an assignment we had to do that was a project charter. You remember that? Could you tell me some of the stuff that should be in a project charter and what the project charter actually does?
Do you want to answer it? All right. So, from what I can remember, I believe a project charter has it kind of gives the overview before the project process begins, kind of like the almost like initiation in a way. So it has like details about I guess maybe the purpose of the project itself, budget that comes along with it, and then the overall timeline that you plan to be able to accomplish and be able to finish your project on time as well. So.
And what is at the very end of that charter? Do you remember what is the bottom line of that charter?
I do not. Do either you two remember by chance?
You guys are killing me. You're hurting me here. Okay, what the bottom line?
Can we ask from the audience here?
Who has to sign at the bottom line of this? Okay, and why? And what does that do? They understand. Okay, and that basically initializes the project, right? Okay, so nice guy, nice job, guys. Okay, okay. I would like to echo Professor Moe's point here that I think everyone did a nice job, excellent job, very professional. And as he mentioned, yeah, it seems like every group did flow charts. Every group really put, and I'm going to say, their 4 years of education into these projects. So, I mean, I can see that at the very beginning of this course for senior projects, I kind of laughed at a group saying that all you're going to do is turn a light on and off. And I actually understand all that is involved in just doing that simple task, especially I'm going to say when you put it on the internet. So we saw all their efforts going into this of what it takes to create these projects and basically use the um, technology and education that they've learned throughout their hopefully just 4 years here at the university. So I would like to thank you for tuning into these projects. We're going to basically take a little break and come back with awards. But before I'll say we take a break, make sure you check out the 2 links. Okay, there's a link to the programs, and you can see the bios of the students, and there is a link to actually vote for best project. Okay, and I have heard that voting is going to be open until 11:30, so we will come back probably a little after 11:30.